share my screen. Okay, your chat box is open. Feel free to open your mic, or just ask me a question, especially if you don't understand. Okay. So then, the first thing we're going to talk about that most of you, I'm sure you know, are the measures of central tendency. Okay, we're going to the bell curve. Remember that back in the day, bell curve? I'll pull it up in a minute. But the mean, median, and mode are the three things that we look for on the bell curve. If they all line up, then I have a normal distribution. Okay, so then that helps me find my standard deviation. Like, what is that? So then, if I look at a normal bell curve, the assumption is that if there's 100 people in the world, that they would fit on the normal bell curve. So, again, facts, things that will never, ever change. The first percentile is 68%. I'm sorry, the first standard deviation is 68%. Okay, so you get that by adding all of these together. Okay. So then 34 and 34 is 68%. That's the first standard deviation. That sign right there means deviation. That's what that means, the sign for the standard deviation. In this here is my mean, median, and mode. If all of those are lined up in the middle, this is a normal distribution. So of the 100 people, 1,000 people, 1,000,000 people in the world, it still would be the same. It is 68%, always, always, always. You get that by adding the 34 and the 34, that's 68%. 13 and 13% gives me my second deviation. My second deviation is like 95 I think it's about 95.34. Sometimes you'll see 96, most often 95. Okay, so the first standard deviation is always going to be 68. First one is 68. The second one is 95. The third one is 99%. That is only if the mode, median, and mean are all lined up. Okay. The assumption is that my mean is the exact average. So I've got 5 numbers. I add the 5 numbers up. I divide by 5. I get my average, right? My mode is the number that appears the most often. And my median is a number in the exact middle. I always remember, because driving on the interstate and there's that green strip in the middle. If I cross the median, I'll probably die. Okay, mean, median, mode. If they're all lined up, they're all the same. I have a normal bell curve, and then 68, 95, and 99. Always facts, will never ever change. Okay, again, that's one thing I like about math when it comes to especially these type of questions. So there's no, first best, next last, none of those. It's a fact. It will never ever change. Okay, and again, that's why I say they're freebies, because if you get these things down, they don't change. There's no figuring it out. It's just a fact. 68, 95, and 99%. Okay, that works great if the mean, median, and mode are all lined up. Okay. Unfortunately, sometimes they're not all lined up. So then I have it's called kurtosis or kurosis, K-U-R-I-S-O-S. Whenever we don't use those, you won't see those terms on tests in a long time. We just say that it's not a normal standard deviation. So sometimes my mean will be it's a skew. So a skewed distribution means that they're not lined up. So in a skewed distribution, the assumption will be that the mode is going to be the highest point. The mode is the highest point because it means that that's the number that appears the most often. So the mode will be the highest point. So what a question you might see will ask you, so then if the mode is to the right of the mean, okay, so my mean is here. If the mode is to the right of my mean, it is a negative skew. It's going to skew to the left, and the tail is going to go to the left, okay? Because the assumption is, and the truth is, the mode is always going to be the highest point, okay? So you'll see a question. So if the mean, we're always looking for the mean. The mean is the best way we figure things out. The median is the one that tells us the least, but the mean is the one that tells us the most. So the question will say, if the mean is to the left or right of the mode, then I know it's a positive or negative skew. The mode's always going to be the highest point. So my mean is here. The mode is then going to be, the mean is going to be to the left of the mode, or you can do the other way, that the mode is the highest point. So therefore my mean is going to be to the left. That's a negative skew. A positive skew, again, mode is the highest point. So my tail is going to go this way. It's like the number line, zeros in the middle, -1, -2, -3, -4, etc. 1, 2, 3, 4. That's how it goes. Okay, so this is a skewed distribution. That means that my mean, median, and mode are not lined up. Okay. And for most of you, you know, what I hear from a lot of people is, you know, I only missed, I was so close. I was only 10 away. I was only 20 away. I was only 15 away. But the truth is, of the 150 questions there are, if you're 10 away, that still means that you missed like, you know, 70 questions. Okay, so these are easy points, I promise you. So I say research your friend, I can't do that. Not true, not true at all. Okay, so then that's my mean, median, and mode. The mean is the average, the median is one in the direct middle, and the mode is one that appears the most often. Okay, just talked about this. That's my skew. Okay, so then if my median, my mean is to the, so it's a positive skew. So my mean is to the right of the mode, positive. Negative, I just said. That's my skew. Okay. So variability just means the number.
Excuse me. Can you say that again? The mean, you say it appears more often, or the mode?
The mode is the number that appears the most often.
Often, okay. And then the mean.
Yes. So I always remember, and I remember this from like undergrad. I saw apple pie with ice cream a la mode, ice cream on top. The mode is always going to be the top. If they don't line up, the mode's going to be the top because that's going to be the number that appears the most often. So on top of your apple pie, you have ice cream a la mode on top. That's what that means. Okay. And this is only if the mean, median, mode don't line up. Okay. The perfect bell curve is they all line up, but if they don't, there's a skew. Okay.
So confusing.
Okay. It's not. It really is not. It's not. Mean, median, mode either line up or they don't. If they don't line up, the assumption is the mode is always going to be the highest point. So then if the question asks me if the mean is to the left or right of the mode, it just tells me whether it's a positive or negative skew. Okay. So my number line goes 1, 2, 3, 4, 5. So it's just going to go up that way because let's say the mean is here and the mode's the highest point. So then it's going to give me a positive skew if the mean is to the right of the mode. Okay. I think a lot of my students have this like block, like, oh my gosh, I can't. But it really isn't. And most of us, we had this awful research teacher and like, oh, I can't, or statistics teacher, and we kind of blocked it out. And I don't know about you, but my undergraduate level, I barely made a C because I was up to my professor's office every day crying. Like, I can't understand this. I think she gave me a C just because I was like there every day. Okay. So then, I talked to you before also about standard deviation. The standard deviation talks about then what we're looking at on my normal bell curve. So those are going to be the same always. Okay, so my first standard deviation is always going to be 68%. Always, always, always. Second one is 95. Third one is 99. Okay, so then if a question asks, so there are a group of students scored 72% on the bell curve. Is that in the first or second standard deviation? That would be in the second one because it's between 68 and 95. That's the second standard deviation. You don't have to, they're not asking you to like figure it out like you did before in the SPSS, maybe back in the college. We're not looking at that. We're just looking at just knowing the facts. If this were a math test, I'd make you have a calculator. We're not doing that. Okay. So again, that's what I said. Mean in the middle, mean, median, mode line up, 68, 95, 99.7. Okay. I'm not going to talk about T or Z scores because those are usually things that are kind of, well, I'll talk about that in just a minute. Okay. Okay. The correlation coefficient. This is usually a pretty common one. Correlation coefficient is my R. So if you'll say R equals, that is all that means. It's the correlation coefficient. Correlation, they're related. They're related. It's a correlation. Coefficient is a number. What I'm looking for is how closely these two things are related. So maybe I have the ACT and the SAT. They actually have a very, very high correlation. Okay, because I'm trying to get into school, and it lets me know, like, wow, if I take the ACT, and you'll see when you went to college the first time, they'll take the ACT or the SAT. Okay, because both those instruments, that's tests, those instruments are measuring the same thing. Okay, you get a different score. You get like 1,500 on the SAT or 27, 28, 29 on the ACT, but they're still equivalent scores. So the correlation coefficient, the relationship, the number, that's the relationship between those two tests, is like a 0.90. Perfect correlation is either a -1 or a +1. Nothing higher than that. Okay, 1.26, 1.27, that doesn't exist. The correlation, the best you can get is -1 or +1. That's all that means. Okay. So then, if I'm looking at the best correlation, what I'll accept was acceptable correlation is 0.70. Anything below that is not acceptable. So if it's a -0.30, not acceptable. If it's a -0.80, it's acceptable. Anything above 0.70, so 0.70, 0.80, 0.90 to 1. Same thing with the negative. -7.0, -8.0, -9.0, all the way to 1. All of those things are acceptable correlations. Okay? And all that means is like there's a 70% chance that these two things are measuring the same thing. Coefficient, number, correlation, relationship. So know that correlation, though, is different than cause and effect. Okay? So right now in our country, coronavirus is up. Gas prices are down. Okay? All we know right now is that's the correlation. These two things happen at the same time. We don't have enough proof to know that coronavirus is up and correlation is down is a cause and effect. My gut tells me, yeah, the fact is that, because of what's happening in the country, the oil prices are probably not as expensive. We're driving less, so that's a reason to drop gas prices down. But I don't know that until I do research. Right now, all I know is they're related. These two things happen. It's a correlation. Okay? When I do research, quantitative numbers, that's numbers, quantitative, will tell me if there's a cause and effect. Okay, so quantitative is the quantity. It's the number I'm looking for. Qualitative is that feeling. Those are very abstract. When you left your doctor, dentist, or anybody you saw recently, or even on the phone, AT&T said, at the end of this phone call, would you please rate us on our service? That is a qualitative. They want to know the quality of what it was like. I don't know if you ever, when you leave Skype, do they ever ask you, how was this for you? They ask you to rate them from 1 through 5. Okay, that's qualitative. They want to know, did you enjoy it? Was it good for you? That's a subjective, right? That's not a fact. That's a subjective research. Okay. But quantitative is the number. Quantitative tells me 6 out of 7 people really enjoyed this. Quantitative is always the quantity, the number. Okay? There's no difference between quantitative or qualitative research when it comes to what works the best. It's just depending on what you're measuring. Okay? So again, 0 means no correlation at all. Okay? 0 is the worst thing ever because I'm looking for some correlation. That means none, none, none. Again, number line. So 0 is in the middle. -1, -2, all that good stuff. 0 means no correlation. Okay, 0.90 is a really good correlation. 0.10, negative or positive, is a perfect correlation. Okay. Reliability. Reliability tells me how reliable it is. Okay. Sorry. One second. Sorry. Someone just called me. I have to make sure she gets in the group. Okay. So then, sorry, I'm going to send her a text. Ask me a question, anything that we've gone over so far. It's okay. I promise you, it's really okay. Just ask me a question. There's not a person in this room that I've tutored individually that has said, "Oh, Miss Pam, I love research." No one's ever said that at all. Okay.
So it's hard to understand.
It's really not. For the problem is that we are very gray thinkers. Most of us in the human services field are very gray. Okay, so in our world, 2 and 2, if they don't get to 4, we're okay with that. That means they've got self-determination and they worked really hard. The closest they could get was like, almost 3. But in the real world, in the math world, those concepts are the same. Math is universal around the world because it's always the same. Math is a hard fact. It will never change. Okay, reliability. Reliability means I do the test over and over and over again. I get the same thing. Okay. So then, when I look at this is okay, if you've ever done this, I apologize, but the dollar store pregnancy test. Somehow, I'm not going to look at the health of my unborn baby based on dollar store pregnancy test. I figure if it's $1, there's probably something wrong with it. Just saying. Okay. So then, a dollar store pregnancy test, I can buy 20 of them, and they all can tell me that I'm negative, not pregnant, but I can still have a baby 9 months later. That's reliability. Every test I took said I was not pregnant, but it wasn't valid. Validity is, does it do what it says it's going to do? Validity is the most important. Reliability then is, can I repeat what it said? Okay? So reliability is repeating it over and over again. The test you take, the LCSW, the LMSW, is extremely reliable. So most of you, if you've taken it more than once, you'll find that your score was probably pretty close to the first time if you didn't do anything different. Okay. So if you ever see me post on Facebook, I'll say, what did you do differently? Because it's reliable. The tests may be, the questions may be different, but it's all measuring the same thing. They're measuring your ethics. They're measuring, do you know what to do in the situation, your critical thinking skills. The tests are extremely reliable. They're also they're valid. They're valid. They're measuring, based on the KSAs, what they think a social worker should know. Okay? So reliable, valid.
Yeah, I get those mixed up all the time.
So reliability, again, is over and over and over again. It will do the same thing. Will they show up? Will the test give me the same? That's reliable. We want people who are reliable in our life, don't we?
Mm-hmm.
Okay. I always think about okay, not that I've ever done this, but that the swipe left, swipe right, that dating app. So then when we see someone on this app, we find them, and you know what? So he tells us he's a doctor, or she tells us she's a brain surgeon, whatever. We're going to go to Facebook and Google and find their name, right? We're going to make sure they're valid. Is that really true? Make sure they're valid first, okay? And the reliability is then, okay, he says he's coming today at 7 to pick me up. Did he come today at 7 to pick me up? He said it's going to be here at 8 o'clock. Did she show up? That's reliability, okay? But validity is the most important, and I don't care if it's reliable if it's not valid. That pregnancy test can be wrong 17 times, but I'm still going to have a baby. It's because it's not valid. Okay. So like I said before, when it comes to reliability, the test has test, retest reliability. What that means is you can take it again and again and again. If you don't do anything different, if you study the exact same material, the exact same way, you're going to get pretty much in the same score. Okay. So you have to do something different to change that because the test is very reliable. internal consistency. So the internal consistency, again, so there's just that's one that we look at, is that's the consistency of the numbers of the inside of the test. Anytime it's internal, it's the test question. Okay, so test questions are very consistent. There are two ways I can prove that. One is split half reliability. I take half and you take half. Okay, I do the first 50, you do the second 50. Okay, that's one way of getting it. The second one then is to look at whether, okay, the split half is either I do the first 50, you do the second 50, or you do the evens, I do the odds. Okay, so if it's a test that's written that way, we should get the same score because it's internal. It's the test questions that are reliable. Okay. So you might have seen this one before, standard error of measurement. The standard error of measurement really, let me go back. Sorry, let me go to validity first before I pick that up. Okay, so validity. Validity just tells me that it does what it's supposed to do. Okay, so face validity tells me that it's that I can look at it and I can tell you what I'm supposed to know. Okay, look at this book. What's in this book? It better be some clinical practice questions, right? Face validity. You look at the outside of it and you can know what it says. That's that simple. Okay. Content validity is what's on the inside. Does this really match what it's supposed to match? If I study this book, am I going to know clinical skills to pass the practice test? Oh, content, face. Okay. There are some tests that are predictive. So when you went to the ACT or the SAT, those have predictive reliability. I'm sorry, predictive validity. They predict how well you will do in college. Okay. The LCSW, the LMSW is not a predictive test. You all know people who have license who are lousy social workers. This is not a predictive test of how well you'll do. So this is just one of those that looking at content and how well do you know the content. Okay. So let's go back just a little bit. I talked about the standard error of measurement. So the standard error of measurement really is, you see it on TV all the time when it comes to like the presidential election or any kind of election. It'll say the president is ahead by 67% with a standard error of measurement of a -4 or -5. All that means is what's the error, the human error that could be possible in that instrument. So all you're really going to do is add or take away those numbers. Okay? So a person scores a 92 on a test. The standard error of measurement is 5. Okay? So then all I'm going to do is I'm going to take that. My answer's not going to help.